Hi there, it's Kamilla with you again, and today we have another unboxing video. And I'm actually very excited because I'm holding a very new product from ST Microelectronics, which is called STWIN Starter Kit. And this stands for SensorTile Wireless Industrial Node. And yes, you're right, that sounds very familiar. About a few months ago, I did an unboxing video for SensorTile box. Although these two products might have a lot of things in common, but they're not the same, this board is specifically designed for industrial IoT applications. And as usual, I'm gonna walk you through the product, discuss the main features as well as potential applications. So let's get started, I can't wait! When you order the starter kit from us, you get the following things. So obviously you get the STWIN core board. You get a protective case for it. You get lithium-ion battery. You get a ST-Link debugger programmer board. And connected to the main board, you get a programming cable. This is what board looks like in the close-up. As you can see, it's packed with numerous components on both sides. But it's still tiny, just compare it to the size of my palm. There's so many components, but to simplify our lives, let's start with sensors first. So on the top right corner, we have our temperature and the humidity sensor. We have here a pressure sensor, and down below we have another digital local temperature sensor. And moving toward the center of the board, we have our 6-directional inertial measurement unit with machine learning core. We have our vibration sensor, our accelerometer, and magnetometer. But don't forget, we have our digital microphone for sound analysis, as well as on the other side we have analog microphone for ultrasound analysis. Let's look into a bigger components on the board. So we have our ST32 microcontroller on the board with processing speed of 120 MHz and 640 kilobytes of RAM. We have a Bluetooth module. We have lots of connectors for expansion capabilities, a USB connector here as well, which can also be used for powering the board. There's a jumper here for powering as well. Also the CN2 connector can be used for powering. And looking at the other side of the board, we have SD card slot. This CN1 can be used for powering. There's a slot for battery. But for more information on individual components, please refer to the user manual on the ST Microelectronics website. So this device was specifically designed for industrial IoT applications, but with predictive maintenance and control monitoring in mind. And in this section of this video, I'd like to highlight 3 main applications of this device. And starting with predictive maintenance and collecting sensor data for this predictive maintenance, because as you know, to collect the sensory data, you have to attach the sensor on the machinery, and this device being very small and robust, but also being operated from a battery, as well as having wireless connectivity capabilities, allows us to collect all of the sensory data from the machinery in real time. But also another application is that the powerful microcontroller on board allows processing some of the data, and which is called decentralized or edge computing. So instead of sending all the data to the cloud and processing it later on, we could do some of the processing at the data collection stage, after data collection straight away. And the last application, the highlight I want to mention is that the board covers a very wide range of frequencies when it comes to collecting a sensor data. We have, so depending on the type of machinery, there are many faults that can occur. And for example, at low frequencies, there are some faults such as imbalance or misalignment of the motor in the machinery. At the medium frequencies, you have faults like worn out gears and bearings, and at high frequencies you have worn cabling and also fault in the cooling of the fan. So at all these frequencies, the board has specific sensors. For example, for low and medium frequency range, you have accelerometers, inertial measurement units, and also magnetometers. So all of this pretty much covers low and medium frequency range, but when it gets to higher frequency range, you need to have vibration sensor, which the board has, as well as for sound analysis. The board has a digital microphone, and for ultrasound analysis it has an analog microphone, so it can pick up all of the faults in with very good sensitivity. So yeah, overall I think this is a great product, and you will see we'll do a lot more with this product. I'm planning to do a project, so please stay tuned. And yeah, I hope the video was very useful, and I'll see you next time. Bye.